So we're looking now at maintainable code as a way to produce robust programs. Now, why we need code to be maintainable or what it is come down to the fact that many people work as teams when building software, and at a later point, maybe somebody needs to do a bug fix once the program's been released, and obviously release an update and make sure everyone downloads those updates. But you will struggle to do fixes or to maintain somebody else's code if it's written in a really kind of unmanageable way, or it's been written in a way that's quite untidy or doesn't make a lot of sense. So we're going to go over three really important things, and one I've actually missed off at the moment. And one of the first things that makes code really maintainable is using something called a subprogram. Remember, we talked about these last year. So functions and procedures are subprograms. So what it is a blueprint for a bunch of stuff to happen. And once you've created that blueprint, you can call on it again and again and again. So all of these instructions here are to ask the user for their password so that we can check they're correct and check that they're actually allowed to use the system. I'm just going to run this for a minute, and we'll see this sub-program being used again and again and again. So obviously it asks for the username and password, and while they are not meeting the criteria expected, it'll ask for them again. So if I took Bib instead of Bob, all right, scroll down, and password 123. No, incorrect details, please try again. What's actually happening is we're calling the subprogram here on line 12. So it says, welcome to Skynet Systems Incorporated, print user validation. So we've done all that. Then it's, there's a function or there's a subprogram here. It's actually a procedure, all right, because there are no return values for a procedure. And what it's doing is it's signposting to this block of code at the top, this reusable area of code. And just by putting that one word in there, we are calling all of these instructions to be done by this subprogram. So the program's still running, obviously, because it's not correct. And we've got a while loop here asking us to try again. So I enter the username and password again. All right, let's do it correctly this time. Bob, and then password. Let me just double check what I've actually put in the code. Be helpful. 1, 2, 3, 4, 5. Okay. Should work fine now. You're now in the system and must re-enter your details for extra security. So we're on this line now. And obviously, the next line after is calling this password subprogram again, this procedure I've written at the top. And so we're reusing that again to ask for the username and password and check it's correct. Put Bob, and then 1, 2, 3, 4, 5. It's all good. Program's ended. So that is, I've left it there for now. So where there's an F there, that must be a mistype. Okay, so I can call the subprogram a third time if I want to. Again and again and again. All right. Using a subprogram is a really good way of making maintainable code, because if you've got a bunch of stuff that the program's going to repeatedly do in different places, like 1, 2, 3 times here, you only need to make changes to this one area of code. So if there's an error here at all, like a logical error or a runtime error, you only need to change it once. And every time you call that subprogram, it's going to call the fixed version. So you only need to make one bug fix or one fix to an error in the code. And every time that subprogram is used, then the fixed version will be what they use. All right, so that's really, really important. That's why we use subprograms as much as possible to make code maintainable. And also, it saves you time. If you want to keep asking the user to enter their username and password at various points in the program, then you're going to want to have something that's reusable as opposed to writing the same code out every single time. Okay, so that's the first point I'm going to make, subprograms. So, in fact, I'll put this here. So subprograms ensure future developers, that's people who code basically, will only need to they'll only need to correct an error once. It also makes it They also make coding easier, as once a working sub program has been made, it can be called multiple times without the coder needing to rewrite all of the instructions it contains. So the first thing, sub-programs. Alright, we'll look at something else now, which is of vital importance, is actually, there we go, comments. So I've just written this as a comment. I'm going to do another comment now, within those triple speech marks. And the next thing we're going to talk about is comments. Code comments ensure future developers who will maintain the code can understand what certain bits of it do. That's pretty straightforward, isn't it? I mean, for example, if I go and, I don't know, here, this sub program checks the username and password. That's a good use of comments, isn't it? So I'm actually putting a comment above there. Alright, and then I can say start of the program, calling the sub program. Yeah, so single one-line comments are really useful there. They help a future software developer know what on earth is actually going on in the code. Okay, ensure future developers who will maintain the code can understand what certain bits of it do and are therefore able to make changes. Well, and finally, pretty straightforward. How do I know that all this code here from line 3 to line 8 is part of this sub-program? It's pretty straightforward. It's all indented. All right. And within the sub-program, there's actually a while loop. How do I know which bits of instruction are being repeated within the loop? Well, I can see the loop is defined on line 5. Yeah. And it's indented 1 in. So there's the first line in. And that tells us it's part of this sub-program. But we know which lines of code are being repeated within that while loop because they are indented underneath line 5. They're indented. So I'm going to use some other key terms here for you now, some key terminology, some tier 3 language. Indents help developers to understand what lines of code belong within a particular programming construct, loop, or if statement. So that's what they're for. This, therefore, makes it easier for a developer to follow the logic of the code they are reading. So it's pretty straightforward for me to know that actually these lines of code are going to be repeated within a while loop because they're indented. Now I could run the program and see that in action. So once I get these two things wrong, this is going to keep repeating again and again and again until I type Bob and 1, 2, 3, 4, 5 in. And I know that these are the lines that are going to get repeated because they're indented. Right? This is all one construct. This is a loop, or what we call iteration. But we know that these instructions are what get repeated each iteration of the loop. So that's how we know that, because of indents. So there we go. The three things that can make code maintainable for future developers are subprograms, because as I say, if you create a subprogram once, this is the whole thing here is a subprogram. All you need to do is just put its name and some brackets afterwards, and you can recall it and run all those lines of code again. All right. So obviously it makes coding easier when you start out, because you only need to get it right once, and then you can keep requesting it again and again and again every time you want to check that they are valid by asking for the username and password. We've got code comments, ensuring that developers in the future, or people who are going to maintain the code in the future, know what on earth is going on. And then finally, indents allow us to understand which lines of code are happening within a particular construct. In this case, this is a while loop, this construct here. And we know that these lines are indented under the while definition, meaning that they are happening as a result of that test, of that set of conditions being met.